Hey everyone! Getting ready for your WAEC, JAMB, or NECO physics exams. Then you know for a fact that questions on electrical energy are going to pop up. Well, today, we're going to tackle it head-on, break it all down so you can walk into that exam hall feeling totally confident. So, are you ready to flip the script? Let's turn this tricky topic into easy marks. Let's do this. Alright, first things first, before we jump into all the math, we've got to get the basics down solid. Let's start with what electrical energy even is. So, what are we really talking about? At its heart, electrical energy is just the power of moving charges. You know, tiny little electrons whizzing through a wire. Every time they move, they are doing work. And that work is what's lighting up your screen right now, what's charging your phone, what's keeping the lights on. It's all about harnessing that flow. Okay, now for the really important part. Every good physicist needs a solid toolkit, right? Well, we are about to build yours for electrical energy. These formulas are your absolute essentials. Get this down and honestly, you're more than halfway there. Alright, this is the big boss, the master formula you've got to know. Energy equals power multiplied by time. It's that simple. Think about it. How much power does your TV use and how long did you watch it for? That's the energy you consumed. But what is power? Good question. Power is just how fast you're using energy. And here's the magic trick. There are 3 different ways to calculate it, and they are all connected by our good old friend Ohm's law. You can use voltage times current, or current squared times resistance, or voltage squared divided by resistance. Seriously, knowing all 3 of these is like having a secret weapon in the exam. And a lot of the time, this electrical energy turns into something we use every single day. Heat. Joule's law is the formula that tells us exactly how much heat we get. And this isn't some abstract idea. It's literally what makes your electric kettle boil water or your toaster brown your bread. That formula, H equals I squared RT, that's the physics behind getting things hot on purpose. Now let's get practical. Let's talk units. In a physics lab, we talk about joules. But when you get the electricity bill, it's in kilowatt hours. So why the 2 different units? Well, a joule is actually a super tiny amount of energy. It's just not practical for measuring a whole house's usage. So we use kilowatt hours instead. And you absolutely have to memorize this conversion. 1 kilowatt hour is 3.6 million joules. Write it down, burn it into your brain, whatever you need to do. Okay, enough theory, enough formulas on a page. Let's see where this stuff actually shows up in the real world all around you. I'm telling you, this stuff is everywhere. We already talked about your kettle using resistance to heat up. But that's just the start. That same electrical energy gets turned into motion in your fan's motor. And hey, ever wondered about those giant power lines? They send electricity at super high voltage on purpose. Why? To keep the current low. Remember, energy loss is I squared R, so a tiny current means way less energy is wasted as heat on its way to your house. Even the way your home is wired with parallel circuits is designed so every single appliance gets the full voltage it needs to work properly. See, it all connects. Alright, deep breath. This is it, the main event. This is why we're here. We are going to take all this knowledge and put it to the test with actual real-deal past exam questions. Let's see what you've got. Okay, first up, a question straight from a past WAEC paper. Read it through carefully. Now, I want you to hit pause on this explainer, seriously, pause it, and give this a shot yourself. Don't worry if you get it wrong, just try. Ready? Pause now. Okay, you back. How did it go? Let's break it down together. First, we know Joule's law for heat is H equals I squared RT. So, boom, option B is correct. But wait, we can't stop there. This is where Ohm's law comes in. If we substitute V over R for I and do the math, we get option C. And if we go back and substitute V over I for R, we get option A. So, A, B, and C are all just different ways of saying the same thing. That means the real answer has to be D. All of the above. Tricky, right? And that right there is the pro tip. Don't just be a formula memorizing machine. You have to understand how they are all linked through Ohm's law. That's how you spot these kinds of questions and not get fooled. Next up, a classic from JAMB. This is a calculation question, the kind you're almost guaranteed to see. It's all about figuring out the cost. You know what to do. Hit pause, get your pen and paper, and solve it. Alright, let's check your work. Step 1, we need the total power. We have 60-watt lamps, that's 300 watts, and 400-watt lamps, that's 400 watts. Add them together, you get 700 watts total. Okay, step 2, energy. Remember, the cost is in kilowatt hours, so we have to convert 700 watts to 0.7 kilowatts. Then, multiply by the 20 hours it was on for. That gives us 14 kilowatt hours. Almost there. Step 3, the cost. Just multiply the energy, 14 kilowatt hours, by the rate, 10 naira per kilowatt. And that gives us a grand total of 140 naira. The answer is D. Now, listen up, because this is super important. The number one mistake people make here, they forget to convert watts to kilowatts. The price is per kilowatt hour, so your power has to be in kilowatts. It's a simple step, but it's so easy to forget in an exam. Don't let that be you. And here we go, our last practice problem. This one's from NECO. This one has a couple of sneaky unit conversions you have to watch out for. Last time, you know the drill. Pause it right here and work it out. Okay, let's finish strong. First, the power conversion. 750 watts becomes 0.75 kilowatts. Easy. Next, the energy. We multiply that 0.75 kilowatts by 24 hours, which gives us 18 kilowatt hours. Now, the cost. But wait, the cost is in kobo. So 18 kilowatt hours times 65 kobo per kilowatt hour, that's 1,170 kobo. But look at the options. They are all in naira. So we have one last step. Convert the kobo to naira. Just divide 1,170 by 100, and you get 11 naira and 70 kobo. The correct option is D. And that question shows us the other huge trap, mixed up units. The cost was given in kobo, but the answers were in naira. You have to be a detective. Always check the units at every single stage of your calculation, and especially check that your final answer matches the units in the options. We've covered a ton of ground. So let's do a quick rapid-fire recap to make sure all the most important stuff is locked into your brain for exam day. Here they are, your cheat sheet, your toolkit, all in one place. Energy is power times time. The three phases of power, Joule's law for heat, and that all-important conversion from kilowatt hours to joules. Seriously, take a screenshot of this, burn it into your memory. And before you go, my final tips. Always, always, always write your units. You'll get marks for it. If you have to draw a diagram, label everything. Double and triple check your unit conversions, watts to kilowatts, kobo to naira. And finally, practice these cost calculations until you can do them in your sleep. I promise you they come up all the time. So there you have it. You've got the tools. You've got the strategies. You are ready to master electrical energy. But think about this for a second. We've talked a lot about the cost of energy, but what's the cost of not having it? Everything we discussed today, it's not just about exam. It's the physics that literally powers our world. So as you study, remember that. You're not just learning to pass a test. You're learning the language of how our modern world works. Now go out there and absolutely ace that exam.